So I'm going to talk about how to calculate and use the student t-test. So we use student t-test to see if there's a difference between two sample means. And this is important to know for later. You may be asked to write a null hypothesis for a t-test. In this case, it would be that the means of the two populations are the same. You have to practice calculating a t-test in class, but you won't be expected to do a t-test in the exam. The thing to be aware of for the exam is the greater the value of t, the more confidence you have that there's a significant difference between the two means. In this example, we've got leaves taken from one species of plant, and some are grown in the sun and some are grown in the shade. And they measure the thickness of the leaves in micrometers. And we've got a mean for the ones in the sun of 210 and a standard deviation of 73. And for those grown in the shade, 158 micrometers and a standard deviation of 34. So our null hypothesis, there's no difference in the thickness between the leaves grown in the sun and the shade. So using the calculation, we get a t-value of 13.3. So what does this calculation mean if you want to try doing this yourself? So this is the mean of sample 1 minus the mean of sample 2. And that's divided by the complete sum of this. So this is the standard deviation, the sample standard deviation of sample 1 divided by the number of individuals in sample 1, which was 7. The standard deviation for sample 2 divided by the number of individuals in sample 2, which again was 7. They're added together, and the whole of that is square rooted. So it's this sum divided by that sum. It comes out at 13.3. That doesn't tell us anything just yet. So how do you know whether you accept or reject the null hypothesis? So you have to compare your value with the critical value for the probability level of 0.05. So how do you know how to do that? Well, first of all, you need to know where you would look in the table that's coming up. You need to know how to work out the degrees of freedom. So degrees of freedom for the t-test is the number of individuals in sample 1 plus the number of individuals in sample 2 minus 2. So in this investigation, there were 7 leaves for sample 1, 7 leaves in sample 2, add them together is 14, minus 2, that's 12. So it's 12 degrees of freedom for this. So what would our degrees of freedom be? So the probability level of 0.05, and we had 12 degrees of freedom, so this is our critical value, 1.782. And then for our conclusion, there are 3 or 4 important steps that you go through. First of all, state whether your calculated value is greater than or less than the critical value. In this case, our calculated value is greater than the critical value of 1.782. Then you need to use this to say whether you're going to accept or reject the null hypothesis. So, if it's greater than, if your calculated value is greater than the critical value, reject the null hypothesis. For all 3 statistical tests that you will do, this means that you have a significance. So there is a significant difference, and you have to use with a difference. You can't say significant results, because t-test looks for a difference. There's a significant difference in the mean thickness of leaves. The next thing that's important to do is state whether the probability, in this case the difference, is due to chance or not. So the probability of the difference in the means being due to chance is less than 5%. So if you were going to calculate your own p-value, which you might do in maths, that p-value would be less than 0.05. Therefore, the amount of light received does affect the thickness. Link it back to the question in a final statement. So out of those 4 points, this one is perhaps the most important one. That if you reject your null hypothesis, the probability of the difference being due to chance is less than 5%. You will use that statement an awful lot. You could be asked to describe how you process your data to compare 2 means, the basics of how you could use a t-test. So you first of all need to calculate a mean and a standard deviation, as you saw in the equation, to be able to put them into the equation. Then you'd use the student's t-test and use a critical values table to see if you've got a significant difference between the 2 populations. Another really common statistical test question you can get is you're given some information and you have to choose the correct statistical test. So remember, a t-test is looking for a difference in mean between two means. So you'll often see the word mean either in a table or in a paragraph, and if you're looking for the difference between means, that means it's a t-test. So here we can see antibody concentrations, see if they're different in girls, and see if the difference between those that were given 2 doses or 3 doses. So they're your two different groups you're looking at. Those that were given 2 doses, those that were given 3 doses, and it's the mean concentration. So the difference in the mean concentration of antibodies between those with 2 doses and those with 3 doses. So it has to be a t-test. You've got 2 groups and you've got means.